That was pretty good. I was pretty slick on my part. On my cell phone, I was able to do shit in a fast way. I impress myself sometimes. Okay, let's get started. We're being recorded. We're on Zoom. Are you Zoom people able to see the screen? Yes or no? Probably no. You probably can't even hear me. Can you hear me?
Yeah, and we could see the screen.
Okay, so you took the test. And I'm sorry, yesterday I finished all the grading and I told you about it, but yesterday was the last day to withdraw. Even if you're doing really badly, I would still not withdraw from the class. If you want my advice, if you want to say, can I still get a B or an A? I'm going to say, sure. The question isn't, can you? The question is, are you going to put a lot of work in between now and either when the final exam is, or because it's the fall semester, bonus you, sometimes I give you some extra time just to ruin your holidays. So if you finish by Christmas or whatever, if you do a lot of work, you can do this. The nice thing, what my calculus students said to me that was kind of nice was they said that if they work, the grades, they can get the grades. There's sometimes, I remember having teachers in the past I worked my buns off for, and the tests were out of the, like, completely from another planet. Your tests are not from another planet. They're ALEKS. They're very similar. I flipped through a bunch of the same types of questions. You should have seen them before. Okay, so putting in some more work and becoming more familiar with them and knowing how to proceed actually pays off in grade. So if you have time between now and the end of the semester, sure. Now I'm going to tell you something about now and the rest of the semester. We're doing trig. We're starting today. We're going to do trig till the end of the semester pretty much. Now there's a lot of stuff in trig. Trig is an interesting subject. It is, I want to say, I lived in a house, the last house I lived in for like 25 years. And my neighbors were all like repairmen, appliance repairmen, and electricians and stuff. And they called me the professor. And I used to use them all the time to fix my appliances and have electrical stuff done. But they only ever came to me twice in 25 years. And they were both math problems that had to do with trig. So all I can tell you is trig has some very useful things in it. And then there's a whole lot of stuff that I have to cover by law. And I will tell you it, and I will give you homework to do it, and you'll have a quiz on it. But it doesn't get any further than that. But don't count on it. And the stuff we do in the beginning, most of the stuff is sort of important. But I'm talking about towards the end. But when we start doing identities, that's the stuff you probably don't ever have to see. So I have to give it to you, and I have to go over it. But the last thing we do is law of sines and cosines. That is useful. Right triangle trig is very useful. That's what they asked me for. But there's a whole bunch of stuff in between that's not that useful. Okay. All right. Any other questions? Where's my blackboard go? Okay. Any questions about the midterm? Here's the thing about the midterm. If you didn't do well on the midterm and you do better on the final and everything on the final is good. So by the way, you all suck at scanning your rooms. You know who you are. The room scans were terrible. I watched them. Did I tell you I watched them? Every single one. You're going to give me a seizure with your spazzing out, or you're not even showing me where you're working from. It's like, and everybody's taking their test in bed. No more bed taking. No, don't. I said this is like an interview. My calculus class is like an interview. And the people are like, one guy had no shirt on, and another guy said he couldn't scan his because he had the dogs out. Do you know what that means? I think I know what that means, and I don't want to know what that means. But yes, could you just maybe understand that I have to watch these and it eats up my day and it's not as fun as other things I could do. So the room scans have to be, I make notes, I'm going to send them out to you and tell you specifically what I didn't care for. Okay. But even so, even though that there's only this much of the course left, 25% for the final, I can count that 20. If I like you, because you're working hard, I only like people who work hard. It's nothing to do with whether I like you or not. But if you're working hard and Alex tells me you're working hard, I can take your final exam grade and replace your midterm grade with that grade. Okay? If you did well on the midterm, but you didn't do well on, no, I don't do that. My other class, I would do that. I don't do that. Just so, as far as the discussions go, they weren't that great. But you have a project to do in this class. Just basically you're doing all the discussions. And so I can use that project grade to replace bad discussion grades if that's what I want to do. And as far as quiz grades go, there's a review things. Those 3 review things I have, you can do those and bring up your quiz grades too. But honestly, let's just focus on the big prize here. The big prize is that final. You need to take the final, do well on the final, and convince me that that final represents you. And then pretty much we can find ways to make anything else work. Okay? The project is another good thing for other reasons. So it's useful. All right. And another thing that happened in my calculus class that disturbed me immensely. I have a high school kid in my calculus class. And I believe she's a junior. She took the PSATs. Isn't that what you usually take your junior year, the PSATs? And she said they let her use Desmos. And I was like, wow, that's amazing. Did you use Desmos? No, I used my calculator. I'm like, do you think people use Desmos? And she says, no, they don't know how to use Desmos. And I was like, oh. If they let you use it on the PSATs, that means they're probably going to let you use it on other standardized tests. Before you know it, this Desmos is going to take over the world. Be on the front of that wave. Know how to use Desmos. And you'll be getting those good grades before the professors figure out that it's giving away answers. Because honestly, good professors don't care. They want you to know pre-calculus, they don't care that Desmos gives you answers fast. Because the answers it gives you are not really important. It's that you need to know what to do with pre-calculus. That's important. Okay. All right. So you don't have any assignments due today or anything? Let me just go back to lessons. Today is the 30th. Mod 9 is due. So you had to do your proposal. Did you all propose something? This is for your project. I just wanted to be something interesting. Alexis. What's interesting to you? How many hobbies or interests? Do you have any that you can share with us publicly? Come on. So you have a friend so I'm going to tell you a sad story so this doesn't happen to you. He's in his 60s. He took care of his parents. They just died. They left him millions of dollars. How nice. This guy has no hobbies or interests. All he ever did was take care of his parents. And now he knows his money is, he just can't spend money on anything. It's cheap as cheap can be. He can eat anywhere he wants. He can go anywhere he wants. And he picks, if you go out to eat with him, he's like, well, pick the McDonald's or the diner or something. Like it's like fancy restaurant. Oh, you mean like Olive Garden? I'm like, no, Olive Garden is not an expensive restaurant. Anyway, don't be that person. You must have some interests. Okay, I know what your interests are. Your interests are, have you ever been on like TikTok and it tells you and it shows you videos of things and it keeps showing you them? Like I keep getting, if I linger too long on a cat video, all I'm getting is cat videos. I don't even like cat videos, but if I just sit there for too long, if I put my phone down, there's a cat video and I pick it up, the next 10 videos are cat videos. What do your videos say when you watch them? What do they show you the most? That's what you really like.
Travel stuff.
Travel stuff. There you go. Could do something exotic about travel. How about you? What? Music? Oh, lots. It's hard to get numbers on music, but they're there. It's just like how successful musicians are, how much money they make, or how many records they put out. There's numbers. Stephanie. Not Stephanie. Tatiana. Tatiana.
My interest. I still do like the gym.
The gym? Oh, the guy who chucked his bench presses for a while. And she wants to aerobics, cardio.
Cardio and just regular.
Sorry, I'm old. I was hollered at before for calling it aerobics. Aerobics is what old women do. Cardio is what everyone calls it now. Okay, so you do cardio. You could track how far you can jog on your thing for 9 days.
9 days.
You need 9 data points. I don't care how many you do. You could do 9 weeks, but then the clerks would be up. This is your personal project. No, I want everyone to do their own. Your proposal is for yourself. Did I make that clear? This proposal is your idea. Octavio is going to do music. Tatiana is going to find something about cardio. And Alexis, did you decide on something?
I guess travel stuff.
Got to find numbers. Don't compare like France to Spain. That would not work. But you could always do, isn't your major business? Is it business? You could track the costs of travel. You know, you could track how much it costs to fly, or a cruises sound nice. You could also look at the data on how old people are on cruises. Because I hear a bunch of old people like me. And my friend who could afford to go on a cruise, but doesn't because they're expensive. Anyway. So, Jake, what are your hobbies and interests? I'm not leaving you off the hook here.
I play basketball and I like to work out.
Okay. So, basketball team, do you have a team you like?
Yeah, I like the Warriors.
Okay. And what do you do when you work out?
This gym near me.
What?
I work out at this gym near me. It's called Simply Fit.
I know, but what do you do there?
Oh, what do I do?
Weights, cardio.
Oh, weights.
Okay, so you could track your bench pressing for 9 days, or
Yeah.
every third day you could figure out what your maximum bench press is. Anyway, good. Christopher, what you up to? What's your interests? I got another couple minutes, so spit it out.
Wait, what?
No, go ahead. Sorry, go on.
Oh no. In the middle of trying to focus on your lecture and hopefully fixing my car because thing's not looking good right now.
What? I missed the second part. What's the topic?
I'm
Your car? Cars are a good topic. Cars that break down, not as fun, but
yeah.
electric cars, track electric cars, you track the average gas mileage, so many things. How reliable cars are, anything you want. Cars, a good topic. Just get the data.
Okay.
Okay, good. David. All right, I'm going to ask everybody. So you're all going to come up with something. The faster you come up with an interest, the faster I move on. All right, now David, I'll come back to David. Joseph, hobby or interest?
Yes, sir.
Give me a hobby or interest.
Let me a second. I'm driving. I just have to go to the college.
Okay.
I'll be there for like the 17 minutes.
This is like pulling teeth, isn't it? All right. Let me tell you why I'm doing it. I'm not trying to get you, I'm not working for the FBI trying to figure out what your hobbies are so we can get your passwords and break into your account. No. I want you all to pick different topics so that we all have a better view of how pre-calculus can be used in many places where you wouldn't expect it to be used. So like, for example, I'm giving a talk in a couple weeks, I hope, on what's the best price to charge for lemonade. But if you have a lemonade stand, it seems like I was trying to think of what would be the most useful thing. Everybody tries to make money on the front. Do you ever try to have a lemonade stand? So what price should you charge? Well, now you know. So before, if I told you this at the beginning of the semester, you couldn't follow what I'm about to say. In this talk, I'm going to create a Desmos worksheet that's going to I'm going to collect data on what people will pay for lemonade. I'm going to put it in the data. And then I'm going to fix it to one of different groups who have different regressions. So some might have linear regression, some might have an exponential regression. And then I'm going to have them take that sales data function and figure out what the sales are. Take that sales regression, you multiply it by X, the price, X being the price. Sales times price is something called revenue. Then you subtract the cost of each item times so you're creating this function in Desmos. I'm just going to create it for them. They don't even have to know any math. I'm trying to make it so they don't know any math. All they have to do is put in the price that it costs them to make lemonade. And then they're going to get a graph from this. Zoop. And that graph, hopefully, they'll click on the maximum like we do on Desmos, and it'll tell you what the best price to charge is. I'm very excited about this. So they'll get that, and then they can adjust. The only thing they can do with the little slider is change how much it costs to make the lemonade. So if they get very expensive lemons or very expensive lemonade or whatever, they may not make any profit at all. That graph will go below the x-axis, and they'll be like, okay, there's no price I can charge. If your lemonade is too expensive, there's not going to be a maximum price because those people aren't going to pay that much. The sales data will prohibit you from selling any at that price. Anyway, I think it's very cool, and I think they could go home with a little Desmos worksheet that they can give their kids and say, look, this is what we can use to figure out. So I think it's cool. But I think you will have something in your future, in your whatever that job might be, in business or in music or at the gym, where you're going to be like, I wonder how long it'll take me to lose 40 pounds. You're not going to lose 40 pounds. But how much, if I do this much cardio and I lose it, let me track and see how I can lose this weight. Or how much I can, how much exercise I can do. How much can I bench press? Yeah. Before I turned a certain age, I wanted to bench press a certain amount. When I got 5, it's like, it's 5 pounds. I needed 5 more pounds and I could have my lifelong gym goal done. And I didn't make it. And now that I'm getting older, the numbers just keep going. It's like, we're so close. Now I'm 25 pounds. No, I was 25 pounds less. Now I'm like 50 pounds less. It's like they ain't happening. Sad. Anyway, you can apply this anywhere. COVID was a great place to find data. But anyway, Momin, what are your hobbies and interests?
I guess I just like working out too. Just like staying fit and all that.
Okay, lots of numbers in the gym. When I go to the gym and people ask me how I'm doing, I'll say my numbers are good, or I'll say my numbers are bad. So yes, you can I track data all the time. When I get an injury, my numbers go down. And I know I'm feeling better when my numbers go back up again. So do that, Moment. Expect some exercise data. Taylor, hobby or interest?
I like working on my car and playing video games.
Oh, video games. Great. Video games are going to replace the world. I can't wait till virtual reality video games come into my life. That I'm looking forward to. I'm just spending all day in bed playing video games. That's how I see my retirement. Okay, Taylor, that's a good one. I like either of those. cars or video games, you can get numbers from either of those. Sebastian. Hobby or interest?
Watch or play soccer.
Okay. You have a team you like? Track them.
Yeah, Barcelona.
Barcelona. Right. Track them. Michael C. Hobby or interest? Here they come. I'm almost done. I got one more minute. What's your hobby? Batching.
I play basketball.
Basketball. Look, sports, music, cars, technology, video games. These are all things I believe you find interesting. I don't want to hear any data on the population of New Jersey or anything like that. If you're going to do height and weight, it better be because you're interested in it. Because I will reject this proposal. I will reject if I don't find it interesting enough. I don't have to be interested in it, but I have to believe that you are. And I will grill you if you say you're interested in a population in New Jersey. You'll get some questions. Why are you interested in it? What should you? And then students get all defensive when I do that. No, don't just pick an interesting topic. Pick something that I think that I believe that you're interested in. Okay? All right. That's what you have to do. That's all you have to do for group work this week is put something down. And it's due tonight, but it's due until I grade them and tell you yes, then you're going to have to do it. But if you don't like it, you want to change it, and I haven't graded it yet, change it. But that's what you're going to look for data also. So you might as well start looking now. That's worth 10% of your grade, but it can also be worth 20% of your grade. So if your discussion grades are not that good, I can eat them up with this. Okay. As I said, final exam was what percent? Final exam is 25% of your grade, but it could be worth 45% of your grade. So there's still time to do good stuff. The final is going to be, though, 2/3 of it is going to come from the stuff we already did in the midterm. Only 1/3 of it is trig. Okay. That's what we got going on. All right. Any other questions? Am I sharing? No. Am I sharing? Yes. Yes. Sure. And we're live streaming. All right. What else is due today? Anything else due today? Quiz number 8. Take a look at quiz number 8. That's due today. Did anyone do it? Or did I say I'd give you more time for quiz number 8? Seven questions. Who did it? Michael did it. Oh, a bunch of people did it. All right, so let's take a look. Okay. I don't think you do it. You did well. I always holler at my colleagues for not doing this, and I'm about to do it right now. But 86% of you know how to convert degrees to radians and radians to degrees. Or at least you learned it that. So I'm going to skip right over that. Do you guys mind? It's pretty easy to convert radians to degrees to radians. I will say this, though, when you're using Desmos, the important thing to know about Desmos, again, if you already know this about Desmos, okay. Okay, do you see in the upper right corner where there's the wrench that I go to sometimes? The wrench to change the to change these things? Yes? The x-axis, y-axis, the measure, some of them. Do you see at the bottom, it says radians in degrees? Do you know this? This is radians. This, right now, if I type in something like 45, it thinks of that as radians, even if I'm saying 45 degrees. If I want it in degrees, I have to go to the little wrench and hit degrees. Now it thinks that 45 is degrees. Okay, the difference between 45 degrees, so pi over 4 radians, that number right there is the same as 45 degrees. So let me take a trig function that you don't know, sine of pi over 4. Okay, so this is a function that's taking an input pi over 4, and it thinks that pi over 4, because of the wrench, it thinks I'm in degrees. Yeah, let me put it this way, 45. So if it thinks I'm in degrees, the sine of 45 degrees gives me 0.707. Okay. If I want the sine of pi over 4 radians, if I do pi over 4, do you know what pi over 4 is? Pi over 4 is about 0.78. So in this case, it's thinking that the input is 0.78. It's thinking this because my calculator is set, or my thing here is set to degrees. So it's thinking virtually no degrees. 78 is like 1 degree. Do you see the difference? If I write 45 degrees, that means pi over 4 radians, but the calculator, Desmos only understands whatever's hit here. So if I change this to radians, watch the numbers change. Bloop, see how the numbers changed? Because now it thinks that 45 is no longer degrees, but that's 45 radians. So that's a lot. And then the sine of pi over 4, watch, if I put in pi over 4, I'll get the same number I had before, 0.707. Because it understands now that pi over 4 is 45 degrees, but it's thinking of it as right now, because of the way it's set, it's thinking of it in radians. Don't make that mistake, because radians are what all the math things are in. To get all the math answers, you have to be in radians. To get all the real life answers, like remember I told you the stuff that was useful to me? The law of sines and cosines and the right triangle trick, that's all in degrees. Because that's the stuff Home Depot understands. You can't go to Home Depot and ask for pi over 4. You want to say, I want my lumber cut to pi over 4 radians. They're not going to know what the hell you're talking about. But if you say 45 degrees, they'll say, okay, I can cut your lumber at 45 degree angle. Okay. All right, so I'm not going to, I said I was going to talk about it, but I did. Let's try the next one. Arc length versus, okay, so arc length. There's a formula for arc length. Okay, and that formula is, I'm just going to click on Alex rather than give you, it's S equals R theta. And here's the picture. S is the arc length. So if you're talking about a piece of pizza, S is the crust. Okay. R is the radius of the pizza, right? If it's by the way, if you get a 10-inch pizza, is that radius 10 or diameter 10? It is. Doesn't it suck? Because a 10-inch pizza is kind of tiny, isn't it? What's the big pizza? That's like a 16-inch pizza. Okay. I'm sorry. Clearly somebody's hungry for pizza. That the radius would be the length of the radius is not the diameter of the pizza, but half that. So if you're looking at a piece of pizza, it's the side of the pizza. Theta is the angle of the pizza that's cut. Okay. What are most pizzas? 8 slices? By the way, when you get to mine, you don't get to eat pizza anymore. So enjoy what you can. 8 slices of pizza. So what would that be as an angle measure? That would be what, 45 degrees, right? You can't use 45 degrees when using this formula. You have to use the pi over 4. Okay, so what you have to do is that skill that you just learned, how to change 45 degrees into radians. That's what you have to do. So this particular one, this example, they say they have a radius is 17, so that's R. And then they tell you the arc length is 18, and they want that measure in radians. Okay, so you're just going to plug in 18 for S and 17 for R, and you're going to get a number in the calculator, which will be 1.05. That's radians. Okay. If you want its degrees, you have to multiply it by 180 over pi, and you'll get the degrees. Okay, let's try another one. Okay, so here, this problem, they're giving you 111 degrees. You can't use it. You have to, you can use that formula. S equals, let me just write it down. Oops, sorry. Really? Come on. I'm still sharing, right? Yes. So you can use this formula S equals R theta. And in this one, they give you, the circle has a radius of 12. And then 111 is the degrees, but then you have to multiply it by pi over 180 to convert it to radians. And then that'll be your answer. Because this answer is in degrees, put a little circle there, and this one is in degrees, so the little circles cancel out. Okay? No, I don't know why I'm writing like a 5-year-old, but that's not. Okay. All right. So this, I don't need to do this. You can see you do S equals R theta. You see how they converted by pi over 180. And they got that answer. It's the arc length. 86% of 71% of you could learn that. Anyway, I shouldn't spend a comment. 86% of you could learn this too, finding the values of trig functions from a point on the unit circle. Okay, so you got this. Really? Okay, so let me just tell you what is pre-calculus. Okay, what is math? Language. What is pre-calculus? Study of functions. We have all the other stuff. There's new functions today, trig functions. Here are the trig functions that are on Desmos, by the way. Just saw one of them. Okay, so they all come from this, x squared plus y squared equals r squared. Now, r is a slider, so let me just start at 0. I'm going to go up to 25. I want you to see something here. That formula, when I asked for it to graph it, what happened to it? Oh, it's 0. Watch what happens to look at the center. Boop, there's a circle of radius. There's a circle of radius 1. There's a circle of radius 2. There's a circle of radius 4. Okay, you see that? All right, so we're talking about a unit circle of radius 1. That's what we're going to start with. Okay? That's a circle of radius 1. So all the functions that we're going to do, we need to be tracking the points on that circle. And so what we do is we say, okay, one of the functions we have is the x coordinate. That's the cosine of, we'll call it theta. Theta. There we go. Cosine theta. Try r equals cosine theta. Okay, so cosine of that cosine, let me do it. Let me create a table. So I'm going to put in values like 0 degrees. What am I in? What am I in here? Degrees. I'm in radians. Let me put in degrees. So I put in 0 degrees, 30 degrees, 45 degrees, 60 degrees, 90 degrees. Okay. The x value on that circle is going to be the cosine. So that's a new function of what's at x1. Okay. That's the x value. The y value is going to be the sine of x1. Okay, so let me just say. So if I look at a point 0.10, see, oh, it's not point coming from. It's coming from here. That's the 0.01. That's all we want. We want to 0.10. So let me just write it this way. So I can write the x coordinate as the cosine of r, the sine of r, and let r equal 0. Oops, I used r too many times. Say that again. I'm in degrees, right? Did anyone remember what I was in?
Yeah, thank you, solution.
Okay, theta equal, sorry, you can't use theta as a function of anything yet. No. Maybe theta one will work. Yeah. Okay, did you see that green dot? Let me make it bigger. How big do you want to make it? I think if I make this 15. See that big green dot? Okay, that's when theta is 0. So it's 0. You see it's at the point 1, 0, and that's where it is on the circle. Now, if I go to 30 degrees, see that dot? See how it's moved? Okay. That dot is at the point 0.86. If I click on it, it'll be, see, as a 0.86603. See how that's the second line down on that column? That's 30 degrees. Let's see what 45 degrees is. See that dot? If I click on it, it's at 0.707, 0.707. You see how this is 0.707 and 0.707. Okay? That's why we invented these strict lines. Those sine and cosine have to do with the x and y coordinates. Okay? And if I keep moving around the circle, if I go to 190 degrees, where will that be? See, all the way around to here. And that's the value. 190 degrees. What about if I put minus 190 degrees? Where's that? That goes around the other way. Okay? Okay. Oops. So what is tangent? Tangent is this. Whoa, that is not what I want. Tangent of theta y. Let me put this back to 45 degrees. 45 degrees, right? I want the y equals x. There we go. What is the tangent? The tangent is the slope of that line. What is the slope of that line to 45 degrees? Does anyone know what the slope of that line is? 45-degree angle. When I go to Home Depot and they cut a 45-degree angle, what's that slope? Goes up 1 and what? Over 1. So the slope is 1. So this is another function. So we have the x coordinate, the y coordinate, and the tangent is the slope of that black line. Okay? Those are 3 new functions. Sine, cosine, tangent. We have more. So remember how we had inverse functions? Remember we had f raised to the -1, and that was the notation for an inverse function. Remember this? That means the inverse of but you know how you put stuff in the denominator like 1 over a function? Remember that? If you have x to the -1, so that means inverse. This means inverse. And this means, since it's not a function, it means 1 over x. Does everyone see that? That's to the negative power? Yes, you understand math is a language. I'm just teaching this up, just a notational point. That little to the -1 means an inverse. So we have new functions. So when I write sine raised to the -1, since it's a function, it's going to mean what? It's going to mean inverse, or is it going to mean 1 over? It's a function. What did I just say about functions? It means what? Is it an inverse or is it 1 over? F to the -1 is a function, but it means inverse. X is not a function to the -1. It means reciprocal. So sine is a function. So when you put sine to the -1st power, what does it mean? Inverse. Thank you. Means inverse. So what if you want 1 over sine? If you want 1 over sine, nobody wants to have to say reciprocal of sine. So this is what they say. they say 1 over the sine of x is not, is actually called the cosecant. Okay? All right, so if I look at this, so let me take at this value right here. So if this value is 0.707, if the sine is 0.707, then the cosecant would be 1 divided by 0.707. So it should be something like 1.41. So if I just ask for the cosecant of theta, which is which one here? Theta 1. As for the cosecant of theta 1, watch, it's going to give me 1.41, blah, blah, blah. Okay? So that's why we invented cosecant, which is CSC. Secant, which is 1 over cosine. Don't ask me why. Here's more functions. So we have this one, 1 over cosine. Is SEC, secant. And then 1 over tangent is cotangent. Yeah. So now we have 6 new functions. How many more you want? Is 6 enough? So basically with this point, I have the x coordinate, the y coordinate. If I want the slope, it's y over x. And if I want these other ones, it's 1 over y, 1 over x, 1 over x over y. So when they give you a problem like this, and they say, finding the trig values from a point, they're telling you the x and y value, and all you have to do, the sine, oh, let me pick one that's different. Okay. The sine, I'll do the sine first. That's the y coordinate. What's the y coordinate here? Yep, 1 over 2. Secant is 1 over the x coordinate. What's the x coordinate here? Right, so to reciprocal it, it'll be this. So I flipped it. And what's the tangent? Tangent is the y coordinate over the x coordinate. What's the y coordinate? Negative 1 over 2. And I want to put that over what? Divided by the x coordinate.
Square.
Right, it's not going to like that answer, but it is correct. It'll say you could have simplified it. See, you could have simplified it. This is a complex fraction. Let me show you what it wants. It wants that. You can simplify these, but it would take the other answers. You don't have to reduce this number. The top one right here, 2 square root of 3 over 3. That's because they rationalized the square root. They moved the square root up by the denominator. I don't care about that. Nobody cares about that anymore. All right. So now we have degrees and radians. We have this arc length formula, and we have 6 new functions. Okay. Now let's talk about this question. Now this one's an easy question. Using a calculator to determine these, you literally just type in what you see into Desmos. Okay. But how do I type in, for example, the cotangent of 13 pi over 8? Okay. And what does it say? Round your answer to the nearest hundredth. So would that be 11.19? Are we sure? All right, let's try the next one. What's the next one? Secant of minus 220. Minus 270. Are you sure this is the answer? Oh, it says undefined. That sounds good because undefined is definitely an answer there. So I'll just go with that. Could be wrong. What about the cosecant of minus 225? By the way, calculators don't always have these functions, but Desmos does. Okay. That says 1.41. Are these answers correct? I can tell you that at least one of them is wrong. I typed in exactly what I saw. What did I show you at the beginning of this whole thing? Remember, I could make the numbers change by doing what? Yeah, what are we in? Do you know? How do I find out? What am I in? So which of these answers is correct? The one where 270 says degrees, the one where 225 says degrees, those are correct. So undefined is correct. This one right here is 1.41. But what about this one? That one's wrong. How do I get that one to be right?
20%.
Change it to radians. Now what would you say it is? Point what? Minus 0.41? And that's correct. Well, whatever. I don't care. Up to deal with that. Do you understand that? So all this is a test of it's these functions, there's nothing hard here. All right. But you understand the settings tell you make them, and they're different questions, they're different things in there. So you want to do that. All right. This is a hard one. 43% of you did not get this one. Okay, so they're giving you, this is definitely that's the most friendly problem. They're giving you a function. They're saying a mass of a spring is moving with simple harmonic motion at the time t and height h. So the time is t and the height is h. It's given by this formula, and they're telling you a is a certain number, w is a certain number, t is a certain number, and c is a certain number. So what's the problem? What happens if I just start plugging things in? H equals a cosine parentheses w t minus c. Okay. And what do they tell us then? Do they tell us what these things are? Can someone tell me what A is? 7.9. Okay. Can someone tell me what W is? Say it. Thank you. Good. Oh, they're even telling us what T is. Okay, what's T? Yeah. What's C? You see how I'm getting pi by just typing in pi? Pops up automatically. All right, so is that the answer? It is. Why is this the hardest question? Is it because you had your thing in degrees? Could you get a different answer from degree? Oopsie. Why? Does anyone want to tell me why they got this answer? Why you got this wrong? I just want to know. Let's try another one. Maybe there. Oh, look at this one. This one. Okay, so those little sub-zeros are just like markers. Like if I said Alexis 2, that would be like just to differentiate you from Alexis 1. There is no Alexis 1. I am Alexis 1. All right, so this is capital H equals, do they give us what V0 is? 100, and has to be squared. Do they tell us it's the sine of sine squared? Ooh, sine squared has to be written that way. 4 pi over 7. And then what? What's G?
9.8.
Two times 9.8. Okay. That's the answer. That seems easy too, is it? Am I oversimplifying this? Is this one of these things that you're gonna tell me how easy it is when you see me do it and then you go home and you're gonna screw it up? I can see a lot of opportunities for mistakes here. The little sub-zero is just a name. It's not times zero or anything. As I said, it's like giving somebody a number that doesn't mean anything. So V0 is given to you, it's a number. And there it's squared. Sign, when you square sign, you put the little 2 there. If you put the little 2 after that means something different. Okay. You'll see when I did the inverse stuff, I wrote the little inverse thing there. You always put, if the power has to do with the trig function, you put the number there. If it has to do what's inside the function, that's something else. Okay, but whenever you're raising the sign to the second power, it goes where that highlighted thing is there. So if I write sine is to the 2 of x, I mean, that literally means this. It means the sine of x. That whole thing, let me put that in parentheses, that whole thing is being squared. Or you could write it as sine of x times sine of x. Okay, you will never say sin, you will always say sine. It's a sin to say sin when you mean sine. Okay? If you leave this class, you go into the next class and you call it sin, you will embarrass me and yourself. Okay? When you see tan, you'll say tan because that's the way it's said. Lucky for you. What about COS? That's cosine. That's not cos. Cosplay is something else. Okay? All right. Everyone understand that? If I put a 3 there, I never see it cubed, but I could. Then that would be cubed, and that would just be times another sign. If I put a minus with that 3, that means this. That means this one divided. That's what it means. Okay. So if you put to the negative third power, it's nothing to do with inverses. Only -1 means inverses. -3 means the same thing it always meant. Okay? But negative, if I change this to a 3, that doesn't mean inverse anymore. Nope. Oop, doesn't mean that. That's what I'm saying. All right, let me go back down here. These are pretty easy, right? So there's no excuse for you not getting these problems. How about this one? They're telling you what A, B, C, and T are. Just make sure you're in radians, and it'll work just fine. Okay? I don't think any of these are hard. Does it? Anyone want to share with me why they were hard? Come on, Tatiana, why was it hard? Did you get it? Did you do it? Somebody did. I'll find out who did it, and then I'm going to ask you. Did you do it? Did you get it? Anyone here get it wrong? 60% of you got who did it got it wrong. Did you really? You tried to do it by hand or with a calculator?
I wouldn't do it yet, but I would have, hopefully would have tried to do it. I didn't.
Okay. Let me tell you, when I had a student about a year ago in my pre-calculus class, and she had pre-calculus before and she failed it. And I showed her stuff on Desmos and I heard her puffing. I was like, what's wrong? She said, this is so much easier than Desmos makes it so easy. The rest of this course, much of it will be too easy to talk about. So that means maybe you understand it. So I don't want you to be memorizing the unit circle. Who memorized the unit circle before? I hate that. Unit circle makes me sick. No. Did you memorize these special angles? Ever hear this? Remember how I put them down? 30, 45. Remember that? Do you know how many special angles there are between 0 and 90? Oh, there's 5. 0, 30, 45, 60, and 90. Those are special angles. There's 5 of them. Do you know how many non-special angles there are? Yeah. All the others. Everything else is an infinite number of angles. And so do you know when you go in life You know how often you use 30, 60, 90? Sometimes when you go to Home Depot, you want a 32 cut, 62 cut, sometimes mostly 45 cut. But anything else is not covered by the special angles. That was only used with old people who didn't have calculators that did those things. You have those things. You should not waste your time memorizing this 33/2, any of that stuff. I'm going to show you how to get around. If Alex asks you for those answers, I'm going to show you how to get around them. There's a way to cheat it. Okay? It's not cheating. I just don't think it's useful. And you know how many times I use it in my calculus, guys? You might say, oh, well, I need it for calculus. No, you won't. Nope, nope, nope. And if you do, you'll probably forget it. And so will everybody else. So if you have a teacher like that, just sit down and memorize it then. Don't waste your time now. You've got too much of it. Honestly, calculus is easier than pre-calculus. So sine, cosine, tangent, ratios, and numbers. Okay. This is nice. It says the right triangle has been created 3, 4, 5 as shown below. Use these lengths to determine the sine, the tangent, and the cosine of that x angle. Okay, so this is kind of out of place. Not really. So let's cover it. I told you the most useful thing I ever did was called right triangle trig. So let's cover it right now.
Professor.
Yes.
So when it doesn't like give you theta, how do we like determine what's opposite and adjacent?
That's in right triangle trig.
Hmm.
Okay, so in right triangle trig, you're going to have an angle. And then across from that angle, cross. Oh, wow, look at that. Let me do it this way. So when you have an angle, the value of the side across from it is called the opposite. So if you're across from an angle, called opposite. Okay. Okay, if you are adjacent, you're not across. Okay, let's just do it this way. If you're the longest side is longest side is the hypotenuse. Have you ever heard that term before? Hypotenuse means the longest side. So in this, what would be the hypotenuse? 3, 4, or 5? So in this case, the hypotenuse is 5. 5. That one doesn't depend on any angle. It's always the one that's across from the right triangle, though. This is why it's called right triangle trig, because it's a 90-degree angle. Okay, so then it would the adjacent is called what? That one's the one that's left. It's also adjacent to that angle. So if you're adjacent to the angle and you're not the hypotenuse, then you're adjacent. In this case, the angle that we're talking about, the angle is labeled capital X. You see the angle capital X? It's labeled here. And what, you know, the hypotenuse is 5. So what's opposite that angle? What's that side on the other side of that angle? Is 3. So the opposite is 3. The adjacent is what's left over. You see how it's next? There's always, well, for every angle, there's always going to be 2 adjacents. But in this case, one of them is a hypotenuse. It's not that one. Got it? That's why I went over that one. So, notation that I'll use for opposite, I'll call it, sometimes I call it OPP. Sometimes I just call it O. For a little hypotenuse, sometimes I call it HYP or H. Adjacent, ADJ, or A. Okay, now, what's the relationship between them? What's the relationship between sine, cosine, and tangent and those opposite side? This is the right triangle thing. And it's called, I call it SOHCAHTOA. Have you ever heard that before, SOHCAHTOA?
Fortunately.
Everybody's heard it before. It took me about 10 years before I would use it. but my students liked it and they used it all the time. So now I'm using it. SOHCAHTOA means what? ESSA, so is the first one. It means sine equals the sine equals, come on, sine equals. Oh, that's fine. Hold on. You cut it out. Sine equals opposite. Let's call it OPP. Opposite over hypotenuse. Do you see that? The S and the O and the H? Or I'll write it this way. S equals O over H. Okay? So, what does CA mean? CA means cosine equals adjacent over hypotenuse. TOA means tangent equals opposite over adjacent. So when they ask you these things, sine of that angle is what? So what's the opposite here? The opposite is what number? Number 3. And the hypotenuse is 5. So that's sine. Sine's opposite of hypotenuse. Tangent is TOA. Opposite, which is 3 over 4. And cosine is adjacent, CA, adjacent, which is what here? 4 over hypotenuse. Okay, and that's it. So SOHCAHTOA. That's how you find that. Can we try another? Okay. So cosine is what? Look where y is now. Y is over here. What's cosine is adjacent over hypotenuse. CA. What's the adjacent to y? Which one is it? 13 or 5? Adjacent. That's the 5. And over the hypotenuse, what's the hypotenuse here? 13. Okay. Sine. Sine is opposite over hypotenuse. What's the opposite here? Over 13. Oh, no, I'm going to ask somebody else. You don't answer. You don't answer. David, you've been here a while. Tangent, TOA. TOA is opposite over adjacent. What's the opposite here?
Okay, so
Opposite of y.
opposite of y is 12
Over
over
adjacent. Adjacent is
5.
5. Very good. Got you on the spot and you did it. All right, I'm going to give everybody a chance. I'll go with you, Octavio. Octavio, what is the cosine of A? Cosine is CA. CA. Adjacent. What's adjacent to the letter A that isn't the hypotenuse? 12 over the hypotenuse. What's the hypotenuse? 13. Very good. I'm sitting in the back. You can't see this. It's 3. 12 over 13. Okay. Mike, sine. Opposite. Opposite of A. Look at the A and look what's as farthest away from it. 5. And the hypotenuse. 13. Yep, very good. Tatiana. Tangent is adjacent over opposite with TOA. O, opposite. What's the opposite? 5 over adjacent. 12. Oh, very good. We're all right. Next one. Yes. Joseph. I wanted to call you Anthony. I'm sorry. Joseph, I was close. Joseph, what's the cosine? of this? Cosine of x. This is x. What is cosine? Adjacent. What's the adjacent? Which one? Adjacent, really? Adjacent sounds close. 9 looks really far. 9 looks kind of opposite. 40 is adjacent. And what's the hypotenuse? It's the biggest size. That's it. Okay, who has not answered? Okay, home. People at home. Wake up. Sebastian. What's the tangent of x? Toa. Come on. Sebastian. Anyone at home. Don't make me call on you.
41.9.
I'm going to call on all of you. What did you say it was?
41.9.
Tangent is 40. Adjacent. No. Tangent is opposite over adjacent. What's the opposite?
So 9.
9.
Over adjacent is
40.
40. Okay. Sine of x. I got Christopher. I got Taylor. Moment. What sign?
Is it 9/41?
9/41. Excellent. Thank you. That was Jake, but it's good enough. Okay. I'm not going to pick on all of you, but I have to tell you, this was exactly what my neighbors asked me. Remember I said I got to ask 2 questions? And it was all this. And this is what it is. Because with Desmos, I don't have, there's a whole lot more of the semester I have to teach you, but with just this information, can you tell me what the angle X is? You don't know, do you? Well, let me just tell you, you could if you were using, let's say, a program like Desmos. If I just type in the cosine X equals 40/41. Do you remember when you type in an equation in Desmos, what does it do? It gives you answers. And by the way, that answer is in what? Oh, it's right there. I can't. Does anyone know how to get it? Here it is. It's looks like it's around 0.22. Is that degrees or radians? Does that look like 0.22 degrees to you, that X value right there? Looks like something. Let me change it to degrees so you can see what the answers into you. So now they've changed. They're not there anymore. I'm going out. I'm going to zoom out until I see a green line. There's a green line. So what do you think of that is? Does it look like it could be around 12 point something degrees? 12.5, 12.6, 12.65, 6667, something like that? Could it be? Could that be what that angle is? About 12 degrees? Could be.
Yeah. Could be.
You can get any angle. So let's see. Anyway, if I did the tangent, if I did the tangent of x, I said the tangent of x equals, what is tangent? 9/40? 9/40. Watch, that line's going to come right back. Same line. Because it's the same angle. Okay. By the way, if you want Desmos to give, so Desmos is being stubborn here. So y'all know if you want 2 things equal to each other, if you ask for a function and you say, and you want the 0 of that function, it'll always tell you the 0 of the function. Boy, yeah, there it is, 12.6803. So if you just put a minus between them, that's how you can trick Desmos into telling you the answer when it doesn't want to. Just change that equal sign to a minus, and then you've got it. Just click on the 0. So we're pulling together all this stuff, but this is not cheating. You know what a 0 is, yes? You know, this is a function that tells you when tangent is equal to 9/40. We're just doing good stuff and saving ourselves having to memorize those special angles that I can't stand. Okay. Okay. Yeah, did this. Okay. Using trig to find the length Ooh, okay. So we're just gonna go right to bed, Desmos again. And we're gonna look at this triangle. Does everyone see the triangle? Can I make it any bigger for you? You see the triangle there? Okay. I see, I think they mean this side right here is 14, and I think they mean this angle here is 61, and I think they put a question mark there because they want the length of the ladder. Tell me, looking at that triangle, what do you know? You know the angle, right? It's 61 degrees. So I'm just gonna change this to degrees. Oh, I'm in degrees. Good, great. 61 degrees. Okay. What to that angle, what is 14? 14 is what?
It's opposite. Wait,
Close.
adjacent?
Yeah, the adjacent is 14 degrees. It's 14. What about the question mark?
That's adjacent.
Right. Yeah. So the adjacent is 14. So what's the question mark? It looks adjacent, but it's not the adjacent. So it's the
No,
what?
it's the opposite.
I appreciate your trying, Christopher, but no, it's the hypotenuse.
Oh,
See how it's the biggest side. All right. That's the question mark here. Question mark. So I have the adjacent is 14, I have the hypotenuse, and I have the angle. Okay, so what of those formulas in SOHCAHTOA, which one had adjacent and hypotenuse in it? Was it so? Was it ka? Was it toa? Which one has adjacent and hypotenuse in it? I'll wait. Adjacent and hypotenuse in it. Does so have adjacent? I see hypotenuse. Do you see adjacent?
Cosine.
No. Cosine has both of them. So I just take that formula right here. I'll take the ka. Here's the ka. What do I know? I know the cosine. Do I know the angle? Yes, it's 61 degrees. Okay. Do I know adjacent? I know that's 14. What do I not know? The hypotenuse. Let's put an X in there. And I will ask Desmos to solve it by turning this one off, looking for that vertical line. Where's that vertical line? Hold on, let me turn these off during reading. Off. Do you see a vertical line? I see a vertical line. Where's that vertical line? Somewhere around what? 29, maybe? How do I get the number exactly when Desmos isn't giving it to me? What did I just tell you to do? Minus sign that, yeah? And then click on that. 28.877. Okay? So that must be the answer here. 28.9. All right. So what about this one? Christopher, you want to redeem yourself here? What's the 14 in relation to that angle? Is it adjacent, hypotenuse, or opposite?
It's the opposite.
14 is opposite. And what's the question mark?
The hypotenuse.
And what uses opposite and hypotenuse? Opposite and hypotenuse is
Secant.
no, we're not doing secant, but it's
Oh, wait.
opposite.
Yeah,
So,
sine. Okay.
so it would be sine of what?
Sine of 73, yeah.
Equals opposite, which is 14 over,
The question. Yeah.
where is that going to be? Right here. Somewhere around that. And how do I get the exact, how do I get it to tell me? 14.69, whatever. All right. 14.6. All right. It should be bigger than the wall, right? If the wall is 614 feet high, you can't have something that's, these look believable. That looks like it could be 73 degrees. You can't trust mathematicians. They draw these pictures and that whatever they draw could be garbage. Okay. All right. That's that.
Are you gonna post them?
What? Post. You want that Desmos thing? You can have it. I'll save it. Just don't let me delete it. I can delete them really fast, as you've seen. But it's already live streaming, so you can always get it from there. I mean, you can't get you can get the video from there. All right, let's see what else we got here. So the quiz 8 is pretty easy, right? All those questions that I went over, they all make sense to you. These last two are just, I gave you these 6 new functions, and then we use them for SOHCAHTOA, which is great. That's the most useful thing ever. So that what happened to the neighbor was he was building a tool or something. He was a tool builder, and he knew this side, and he knew 2 of the sides, and he wanted to know what the angle was between them of a right triangle trick. So I did exactly what we just did there. I put it in. This was back in the olden days, though. I had to use Siri to tell me what the answer was. Okay, any questions on this, though? Because I didn't have Desmos back then. All right, these are good. So we're happy with that, and we think we understand that. That's due, when is that due? Tonight? Do you think you can finish that tonight for midnight? It seems pretty easy. And you can watch this video again if you want. Okay, so the next thing that we're going to do, the next discussion you have that's due next week, this is called sign regression. Okay?
What's the one due this week?
Proposal. Whatever, your data, what's your hobbies and interests? Jay, what are you interested in? David, what are you interested in?
Soccer.
Soccer, there's numbers in soccer. I like that. How about you, Jay?
Football.
Oh, sure. American soccer. You can do sports. I've heard, there's a whole bunch of ideas on my website if you want to look, but anything with numbers is fine. You're really into these sports, that's all. Just sports. What's your major?
Business.
Business? What type of business you want to go into? Finance? There's lots of money. There's lots of numbers in finance. Track the price of gold.
How it never depreciates over time. Oh, it's like exponentially grows in value.
See, all very good topics. Money is, there's a lot of numbers in money. David, what are you going to do with sports? Soccer.
I'm like a project.
Yeah, sure.
Can you explain to me the project again?
Project is you're going to do what we did as a group, but you're going to do it just for you. And it better be something you're interested in. I don't want to, I want energy. I want excitement. I do not want, do you think he'll take this population in New Jersey topic because I can find that easy? No. I want you to explore your passions. Find something you like. As long as it's not X-rated. I don't care.
The proposal is an independent one.
It's your own. Yep. And it's going to help your discussion grade if you do well on it.
And do we do like the same format?
You're doing everything the same. Ain't nothing new except
Like the same balance.
you're going to do all the same. You're going to do what you produced, but you're going to have to do everything is to do the writer and you have to do the writer and the speaker for every one of them, all the different regressions and whatever, and then you're going to present them. But you're not going to present all of them. You're only going to present the things that you're going to make a prediction and you're going to tell us why you predicted this. We did all these regressions. We did linear and quadratic and cubic and quadratic and exponential and stuff like that. You're going to do those regressions and you're going to predict something. So Tatiana is going to predict how many Cheetos she can eat to lose 50 pounds. I don't know how much cardio she has to use, but she's going to make a prediction and she's going to try to convince us that her prediction is good. And Jay, you're going to predict the price of gold. You're going to try to sell us all on investing in gold because it's going to go up, up, up in the next few weeks. Whatever. You understand what I'm saying? One of the things here, I heard that music in the 70s was the best. I should say the best. I'm not talking about disco, because disco's in the 70s. I'm talking about all music. What? What? No. All music in the 70s was the best. And I'm going to convince you of this because this guy told me. Actually, he didn't tell me why. He just said, he was a music professor here. And he said, all the music, the best, everything, rap, hip hop, soul, R&B, all of that was the best in the 70s. I was like, they had rap music in the 70s. And they said, oh yeah, they did. Like, really? I thought that was like a new thing. No. It was totally there in the 70s, and it was better than anything they produced
Was
today.
Michael Jackson in the 70s?
The beginning of the 70s, yes. He was. He was part of the Jackson 5. Anyway, why? So, you know how you convinced someone? What? I don't know if he convinced me of this. You know why I was convinced of it? Because, do you know where all these old musicians? I was watching Stevie Nicks. I know you guys don't know Stevie Nicks. She was on Saturday Night Live last weekend. Did anyone watch Saturday Night Live? So you don't even watch Saturday Night Live. You just watch the YouTube.
Be good. I don't have anyone entertaining.
I know. You have to. What I do to watch it is I TiVo it and I zip through it. So you can watch YouTube snippets just as easy. Anyway, and they are boring, terrible. Wait till somebody tells me there's a good skit and then I watch it. Anyway, Stevie Nicks was on. Stevie Nicks is from the 70s. She's a multimillionaire. All those musicians from the 70s are multimillionaires. And you know why? Because there was a lot of money in music. In the 80s, when Michael Jackson did his videos, they were music videos. And then they went, because those people were wealthy and they made videos. And then that money from producing videos went to producing movies. So 80s movies started to get better. You don't watch a lot of 70s movies, do you? You know, they're kind of bad. They're grainy and just poorly done because there wasn't a lot of money in them. Now, there's a lot of money in movies, yes? But that's going to dry up soon too. Who's replacing movies? Anyone have an idea of where the money's going to go next? I think. I said it earlier, didn't I? Video games. Oh, how fun it will be when I can, instead of watching a movie, go do a virtual reality tour of Paris. I do that now already over YouTube, but wouldn't it be nice to just be there and interact with people? Excuse me, miss. Where is that Champs-Elysees? Oh, you just go around the corner. Oh, and I'm going, they got this new Disney thing. I just saw it the other day. Disney made a thing where you can walk and not go anywhere. You can go in all different directions and not go anywhere. My walking tour of Paris is going to be there. It's going to happen. I'm going to be walking around the city of Paris, interacting with people, and it'll all be fake. Because people will not be there, but I won't know any better because they're all AI generated. Doesn't that sound like fun? Is that better than watching a movie? And you know what? They'll put plots in it. I'll be walking through Paris and there'll be a crime right in front of me. I'll be like, oh my God, somebody just got hit by that car. The cops will ask me questions and it'll be a mystery and I'll solve the mystery and that sounds so much better than a movie. Anyway, I'm sorry. I'm just fantasizing about what your future will be. But when that happens, the movies are going to be boring. No one's going to go to a regular. Oh, you sat in a theater? Those are disgusting. Was there somebody breathing next to you? Was there gum on the chair? Anyway, do you understand what I'm saying? So money, whatever. I'm sorry. I'm getting all excited. I really want to do that virtual reality thing. It's so close. With a hologram on Star Trek, but I think that's too far. I don't think that's going to happen. You know what a hologram is. All right. Let's talk about the next thing that you have to do because it lead us in. So the next thing you have to do is called the sign regression, and that's mod 9. So let's talk. You already have these skills on Desmos. So let's just talk about them. Hold on. I need to decide something here. Am I going to go to quiz 9? Look at this to see what you have on quiz 9? Or am I going to talk to you about it? Let you know. Let's see. Oops. It's not what I wanted. Sorry. I'm still so excited about going to Paris without having to, and still being near a bathroom at all times. And that's not fun? Okay. All right, so what's happening next? What's in quiz 9? Where are we going here? We're going to sketch the graph of sine functions. Now that we have these sine functions and cosine functions, there one popped up just there. We can graph them. We can talk about them. They're going to have properties. Okay. And we're going to sketch. And we're going to talk about amplitude, period, phase shift. You know how those things, the other functions had end behavior, and because trig functions have amplitude, period, and phase shift. So we're going to need to know what those mean. And then we're going to have to be able to write a graph. But we already know how to do this. We have all the pieces already together. We're just doing another function. These are 6 more functions. But if we're just taking all the pieces that we already know and building on it, it's not so bad. When we go into Desmos, let me just turn off everything, right? And let me, for the functions, make sure I'm in radians, because degrees is not pleasant. I mean, sometimes I do, but anyway, if I want to see a sine function, that's what the sine function looks like. It has a period because you know how you have like marking periods or classroom periods, or a woman has her period. These are all regular things. Okay, so this is this is the top of this hill, and it happens again, and it happens again. Okay, so how far apart are they? Okay, well, let's not look. This is 3 pi over 2, and this one's pi over 2. But let's look at pi over 2 and 5 pi over 2. What's the difference between 1 pi over 2 and 5 pi over 2s? 1 pi over 2 and 5 pi over 2s? What's the difference between 1 apple and 5 apples? Thank you. 4 apples. 4 pi over 2. What's 4 pi over 2? 4 pi over 2 is just 2 pi. This has a period of 2 pi. So the sine function has a period equals 2 pi. Okay. Okay, amplitude. Amplitude, anyone? Amplitude in English. Let me Google the word amplitude. I feel like there's an English word for amplitude. What is the amplitude? Amplitude in physics is the maximum displacement or distance moved over a point of vibrating body. When you listen to AM radio, it means amplitude modulation. Nobody listens to AM radio, do you? No, that's so sad that I even know what that term is. Amplitude modulation means it's how far the displacement is. So radio waves are traveling in the air, and they change the amplitude is to change the maximum value. So a low radio station has low amplitude, and then it gets bigger and bigger and bigger. The amplitude, so that's what amplitude means. So for our Desmos thing, the amplitude for this, for the sine function, is how high up it goes and how far down it goes, but just to one value, not the whole distance between top and bottom. So the top here is 1, and the bottom here is -1, but the amplitude is just that 1. So amplitude is the maximum displacement. So you have a center line, and it's displacing from it by 1 in both directions. So the amplitude here is 1. Okay. And the phase shift is 0 because it's starting at the origin. Where it starts, where the sine function starts and goes up, that's it's not shifted. Now, let me show you what happens when we shift, when we play around with it, which we can do on Desmos. So cool. Y equals A sine X. I'm adding a slider here. So do you see the green line versus the purple line? They're both the same now because the slider is 1. But watch what happens when I take the slider and raise it up to 2, to 2, to 3, to 4. Do you see the amplitude is growing? Whoa. 6 times. Wow. Notice what happens. the zeros stay the same. The amplitude changing it by multiplying 6 just pulled them up. Went up 6 times higher and it stretched it, just like we know stretch it. So just stretch it. The amplitude is just the stretching, it's the number in front. We knew that, right? So the amplitude is just the number in front. So in this case, the amplitude would be what? 6. Okay, someone see that? It goes up, down, up and down 6. Okay, what about the periods? Where does that come from? I'm just going to leave the A there, but I'm going to. Let's talk about B. I'm going to create a period. So let's create the B. Does everyone see the O? And that's I have to put an A in there. The A is 1. Okay, so now let's look at the B. So do you see the green line? Whoa, look what it does. Ooh, it looks like you see that? What's happening? When the B number gets bigger, the period, remember that period was 2 pi before? Do you see what happens when the B, when I'm raising the B, it's actually getting, the period's getting smaller. If I sat here and tried to figure out what the period was between here and here, in this number and that number, I could just subtract them. It's like point something. But let me tell you how you get it. The period, so the amplitude is A. Okay, the period is 2 pi divided by B. So as B gets bigger, the period gets smaller. When B gets smaller, so here it is at 1. But what if I make it a half? If I do that, do you see how the period is twice as big? In other words, it starts here at 0, and then it just takes twice as long. It goes for green to go through 1 period. Purple has gone through 2 periods. It's got twice as big. Okay. In other words, I think we talked about this before. The amplitude or the stretching on the outside goes like this, but when you put a number inside a function, it smushes or pulls. So it smushes it in or pulls it out. But it doesn't change the amplitude. You see how the amplitude isn't changing? Look at this the whole time. The amplitude is always the same. Does everyone see that? The amplitude is always the same. It's never going higher or lower. It's just getting busier or lazier. Lazy. Wait. Lazy. Busy. Got it? What happens if it's a negative number? It just switches it. Negative numbers just flip it this way. So we'll just keep it positive. So we'll leave B at 1. What does A do when it's negative? It flips it the other way. So a negative A flips it. And then keep stretching it. All right, so let's leave that at 1. So they're both at 1 now. Are we good? We're good now. Now let's do something else. Let's do a phase shift in here. Okay, let's see. Okay, so when C is 0, there's no phase shift. See that? But now when C is, let's make it, when C is 1, look what happened to our graph. The purple graph is the original graph, but what's the green graph look like? It's moved what? 1 in which direction? See the red dot? That used to be where it started. Now it's starting 1 over to the what?
Left.
To the left. And remember, if you put +1 inside a function, it moves it to the left by 1. So that's what it did. So what is the phase shift? The phase shift, so the phase shift is really where this B plus is equal to 0. Remember I showed you how to do it. When you shift things, all you have to do is set that equal to 0. So you're going to take BX plus C, let me make it capitals. BX plus C equals 0. That's your phase shift. Or you can call it minus C over B. Okay. So that just moves it. Here's the problem that we have. So watch this. This is where we're going to get messed up. What if I give but I make C equal to 1, right? Just leave it there. C was 1. That moved it to the left by 1, right? We're good? What happens if I change B, the period, to something else, like let's say 2? Do you see that it's no longer starting at 1 anymore here? It's starting at -0.5. Changing that B definitely changed the phase shift. It's starting there. But it's still, just solve this. Just solve Bx plus C equals 0, and you'll see minus C over B is 0.5. Minus 0.5. By the way, there's more. This would also, not this one, but this would also be a phase shift. This answer is a phase shift. This answer. Those are all the same answers because these functions repeat periodically. So you can move them by more and you get the same graph. Okay. So that's the new stuff you need to know. Period, amplitude, phase shift. You need to be able to, when you see a graph, you need to be able to tell me what it is, what the period, amplitude, phase shift is. And you also should be able to figure out what A, B, and C are to give you that period, amplitude, phase shift. So let me just, everybody close your eyes. Stupid. Okay. Don't look. Just gonna hide these. I'll hide them this way. Look at this graph and tell me some things that you can see from it. Not the purple, but the green. Can you tell me what the amplitude is? How high up and down does it go? Click at the top. How far up does it go?
4.5.
Oh, 4.5. The number says it right there.
Still 4.
5.
Oh, it's 5. Oh, yeah.
Okay, oops, so I'm totally. All right, how'd that happen? So I know the amplitude is 5. So that's equal to A. So now I know what A is. Okay, now what's the period? That's the next thing I'm going to do. Period. I sort of mentioned this before. Look at the two top values and subtract them. So I'll take this 9 point. You know, let's to make it easy, I'll make them these two values. So that's 22.2743. I've copied that one down, put it here. And I take this one in here. 9 point blah 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 blah. And subtract them, and that's going to tell me what the period is. That's the period. Now the period is 2 pi over b. So what's b equal to? Oh, hold on, I lost that number. It's this number, 12 point whatever. If that's the period, right? Why it's right there. What happened? Why do I keep, why are my secrets being revealed? You're supposed to not be there. Okay, so what's the period? If I know that the period is 12, period is 12, and then 12 equals 2 pi over b, what does b equal? Can I just solve that? If you guys know how to solve these equations, why can't you just tell me how to do it? Let's do it this way. Get rid of this. Change that b to an x. And look on the graph. Where's the blue line? There it is. What's that? Well, I can't get the blue line, so I'll put a minus there. And what am I going to get? What's that number? 1/2. So now I know b equals 1/2. So I got, now I have the a and then the b. Now how do I get the phase shift? That's the hardest one. Remember I told you there were lots of phase shifts. There, where it starts in the middle and goes up. Where is it starting in the middle and going up? Oh, I'm running out of time. Here's one, -6. Is that in the middle going up, or is this one in the middle going up? 2.83, or is this one at 6.525? Which one? In the middle going up. Which one? Any, not this one, that's in the middle going down. Do you see how that's in the middle and it's going down? This one's in the middle going up. So I'm gonna go with 6.5, that one. I'll copy that. I'll paste it, and that's the phase shift. Phase shift, which is equal to minus C over B. Okay, so let's just take this, copy it, paste it. Did you tell me we knew what one of them was? What's B? 1/2. Okay, so now how do I find C? An X in C. There's the line. Interesting. And then what? To get the number. Answer is what? 3.28 something, something, something. Really? That's not what I put in, is it? Am I in degrees? No, I'm in radians. What did I say A, B, and C were? I put A in as 5. We got that one, right? We got A as 5? Yes, we got A as 5. We got the period is 12.56. Then we got B as 1/2. I put B in as 1/2. C should have been 3. What did we get? It's not 3. Where'd it go? I gotta clear this away. I got 3.2. I got minus 3 point something. Remember I said there's more than one. So this is because I picked this one over here. Let me pick this one, -6. If I let C equal -6, right? Not C equals -6. Instead of 6.25, if I put in -6, that's the phase shift -6. I put a -6 in here. Where's the answer going to give me? It's right here. It's -3. So that's the answer. That's what C is. C is -3. And is that what I put in? I put in +3. Oh. -3. So wait, I use -6. B is 1/2, negative. That should be a positive number. Why is Desmos? Oh, because I forgot to do this. Remember, equals -6. And then we have to change that to a minus sign, and then we get positive. Then we get +3. C equals 3. Okay. All right, so we can take the information and we can synthesize this stuff out. One last thing that I have to do. I'm sorry I didn't do this. So you can graph all these things in Desmos and you can get the amplitudes and the stuff. And there's a midline. Sometimes things go up and down. You have to figure that out. But one last thing I want to show you, and I'm sorry to get to it. Let me do it quickly. The thing you're going to do for next week is the sign regression. And if I just talked too long. That's my problem. Okay, so let me maybe discussions. No, sorry. Let's see this discussions here. What you're doing next week is the next regression. You've already done exponential growth, right? The next thing is the sign regression. You just click on that button and it automatically gives you sign regression. Here's your data, sign regression. Here's the problem with sign regression is it's not giving you sign regression. I lie. It'll do that. It looks good, but you can change something. You can change this A value is that thing with the period. It changes the period. So you can change the period and it still looks good, doesn't it? Maybe it looks better. Maybe that looks better. Okay. You have to specify for this. You don't have to specify the period, but specifying the period gives you the ability to change the answer. And when you say the regressions, when you make your predictions, like I was saying before, You can, so now it's already set up. I chose that one. I chose a period of 45. It looks like I chose a period of 45. So minus 1.7 to 43, that's 45. So that number right there, that A equals 5, that's my period. Okay, and I already have values for X. I can pick any values I want. I can pick 2, I can pick 3, I can pick 4, but I can also solve. And the way I solve is if I want to solve 500, I do exactly what we did before. I look for the intersection. What's the intersection? 10.2 something something. I plug that in here. Do you see how I'm just doing an evaluate and solve just like I did before? Evaluate, solve. The only thing I'm doing different in my groups is discussing the period. But we're technically out of time. But tell you what, why don't you get into your groups and decide who's going to do what? Because this is all you just have to decide on the period if you can. You have a minute if you want to do it. If not, I got people at home. Are these people your people? Who are your people?
Jimmy and I forget the rest of their names.
I suppose we could do it next week. Because I don't know who Taylor, Sebastian, Christopher, Jake. You guys know what groups you're in? No. All right, so we'll do it next week, beginning. You can do them all. In the meantime, you can do those for homework.
The projects due today.
Just your topic. This will be due next time, but we'll do it next time. So that was a lot to do today. Sorry, I talked a lot. Didn't get Tatiana up off of her feet. So now she's gonna get you some cardio. All right. Have a good day. Good. Wait, I have to take attendance. Did I get everybody? Can y'all tell me your names quickly before I just to make sure I get you all? Because I don't know what his name is. Not you. You're Anthony. Joseph. But he is somebody else. I've forgotten his name already. Okay. Justin, not here. Joseph, here you can go. Michael Charles, is that you? No. You're the other Michael Charles. Michael Charles was here though. He was on the computer. Sebastian was here on the computer. Emilio was not here. Taylor was here. Octavio's here. Tatiana's here. Jake was here on the computer. Christopher was here on the computer. David's right here. Genesis. Was Genesis here? Akash. Dennis. Jimmy. Alexis is here. Moman was here. AJ's here. This is you, the other Michael? Just never here. Alejandro was not here. Okay, took your attendance. You can go. Next time we'll do the sign regression, but you see, we're just pulling all the pieces together with it. So even though there are new functions, they're just the same, they're just functions. Don't get all stressed about that. Oh yeah, where do you want it? Put it in announcements. You got it. Take care. Have a good day. You can leave. I have to not forget to do this though. So just.
Give you 1 second.
But this was the whole thing. Okay, good. Save it, copy it, put it in announcements. So what is today? Today's day 9. Day 9 later. Decimals like day. Sure. But yeah, it's like 10:30. Today's mischief night. You don't even know what that is to you.
You know the shit matter.
Well, you better not be soaping out my car.
No, that was high school.
That was high school.
Now
Now
I
you
can-
use
Now I can-
actual hammer.
Now I can actually get arrested, so no more of that. So for the project, would this be fine? So this was the original price for gold the past 5 years. This is the projections.
Are you really doing the price of gold?
I kind of thought it was kind of interesting.
Okay.
So
9, you need 9 data points. No, you don't. You can make the predictions, but they don't. I mean, in other words, your data, can you go up for your data? You need 9 data points. Do you have 9 data points? Yes, that's perfect. Wonderful. Those 2021 to You have
Yeah,
all the.
I would add an order a little bit.
I do not want to see any 2025s or 2026s because they
Okay,
didn't
so
happen.
could just do the past 5 years?
Nine
past
years.
9 years?
That's fine.
So I don't need,
Perfect.
okay, so I don't need.
No, you're gonna make predictions. Those are for your predictions and that's perfect. Those are all evaluations
Yeah.
with the exponential. To get a solve, you have to draw a line. You have to say, when is it gonna reach 4,000? So you have to do, gonna go up to the y equals. Said that from 250, change it to $4,000. Wow. Yeah, bold is really, and it'll draw a horizontal line right here. There it is. So click for that. That's 2028.99. Put that on your table and you've got your solve. No, that's your data. You just messed your data up. Sorry. Go down. There we go. Yeah, to this table. Just replace any of those points.
So 2028 is right here.
Put point, whatever the decimal places were. No, you lost them.
This is it, yeah. This is,
Is it 20? No, that's 2029. That you're clicking on the red dot. You want to click on where the blue lines meet. There happens to be a red dot really close, but not exactly. See the red dot is a little north of the intersection. Click. See?
so this.
0.99282, 28.99282. 28.99282. You see now the price is like 4,000. It was close in 2029, but that's when it exactly happens. Like December 30th of 2029, it's gonna reach
So
4,000.
just post this and then just,
I mean, post it, that's just part of your thing. You've got a whole lot of stuff to do.
okay,
Oh, you're doing it.
the
No,
project.
this is for your project. Yeah, no, that's for your part. You have to do them all. You have to go through them all and convince me that exponential is the one you want. I would turn them all on at one time and make some busy thing
Okay,
and then turn them off and keep only the one you want.
and where do we post it? Because this is due tonight, right?
No.
Oh, I thought, okay, I just
No,
rushed
the
it.
only thing that's due tonight, boy, I'm glad I rushed you. No, all you have to do then is tell me what your data is and what you're gonna do. And you're gonna do that, the price of gold, that's fine.
Yeah. And where do we post that though? Because there's nothing on discussion.
Oh, well, there will be. It's just a thing, it's just for you to propose, hold on. Let me just kill this. Are there anybody at home? Wait, it's Wednesday, I don't have to hang around. Hold on, how do I turn the live stream off? I have to stop sharing. And then I can turn the live stream off.